Alright, in this video I'll be doing the problems on the review for the AIM final. So on number 1 here it asks us to use the quadratic formula. So notice this is in standard form, so the coefficients of x squared, x, and our constant, that's where we get a, b, and c from. So in this problem here, a is 2, b is -4, and c is 5. So again, as long as it's written in descending order equal to 0, you can identify a, b, and c. It's got to be in that form. So now I'm going to write out the quadratic formula. Let me go ahead and make a shell. And now let's plug in our numbers. So here b we can see is -4, a is 2, and c is 5. Alright, so -4, that's going to be a +4. We need to simplify what's in the radical there. It's going to be 16 minus 24, and so, I'm sorry, 16 minus 40, which is -24, so that's what you should get. If you find yourself making mistakes at that step, I would encourage you to put that part into the calculator. You've got to have that right. In the denominator we have 2 times 2, so that's going to be 4. And so now when we look at the radical here, if we're going to simplify this, we first need to make sure our radical is simplified. And it's certainly not, because we know it's going to be an imaginary number since we're taking the square root of a negative. So let me write this over here as the square root of -1. Now the other thing to look at is, does 24 have any perfect square factors other than 1? So these are the kinds of factors we're looking for. And of course 4 times 6 is 24, so we can break this down into the square root of 4 times square root of 6. Notice the 6 does not have a perfect square factor. So we're going to end up with, of course, square root of -1 is I, and the square root of 4 is 2, so we get 2i square root of 6. So I'm going to go ahead and replace the square root of -24 with its simplified form. And so now let's write this as 2 fractions, 4 over 4, plus or minus 2i square root of 6 over 4. So we're going to get 1 plus or minus. Notice 2 divide 4 there, that's going to be a half. So we'll end up with I square root of 6 over 2, or 1i square root of 6 over 2. The other way you could have written your answer here would be 2 plus or minus I square root of 6 all over 2. Now when you look at number 2, you have the choice of how you want to solve this. For quadratic equations, we have a number of different ways. We always want to try to factor first. Really, quadratic formula is one of the last things we look for. But in this problem, I think we should try factoring it first. If not, then we can always go to another method. I want to get 0 on one side and everything else on the other, so in order to keep x squared positive, I'm going to subtract 16x and 36 from both sides. Now on the left side, none of those are like terms, so we'll just write them in descending order. The order does matter here. And then we have 0 on the right. So we're going to use the AC method, or some of you may know it as the split B method, and or another method, but we're looking for two numbers that multiply to -36 and that add to -16. Certainly 1 and 36, I'm not going to be able to make that work. But how about 2 and 18? We need opposite signs because our product, when we multiply, we should get -36. And we need the two numbers to add up to -16. So I'm going to need the bigger number to be negative and the smaller number to be positive. So notice 2 times -18 is -36, and 2 plus -18 is -16. So I'm just rewriting over here the problem so I have a little more space. And we need to split our b term, the -16x, into the 2x and the -18x that we just got, using the 2 and the -18 we just got. And then we can now factor by grouping. So let's group the first two terms, and we can factor out an x. And notice we can factor out a -18 for the second two terms. Now, the way I normally do these is I know I'm expecting to get an x plus 2 factor here, because what's in the parentheses should be the same for both anytime we factor by grouping. And so all I need here is a negative 18 times x to get the negative 18x. And notice negative 18 times 2 gives you the negative 36. So finally, our common factor is x plus 2. And then the other factor would be x minus 18. And that's still an equation. Now, some of you may be wondering why I showed what we did in here, because you know that anytime this is a 1, it's a 1x squared here, we can just take the numbers we found and plug them in, and that's what we have here. So you can certainly take that shortcut if you see it, but otherwise you would do it like we did here using the AC method. Alright, so let's go ahead and set each of our factors equal to 0. When we set x plus 2 equal to 0, we'll want to subtract 2 on both sides, and we get x equals negative 2. When we set x minus 18 equal to 0, we get x equals 18. Alright, let's look at number 3. So again, we have the choice here of using whatever method we want. We certainly could like FOIL the left side, because we'd have to multiply 2 of those 3x plus 1s and then get everything on one side, 0 on the other, and I think you'd have to use the quadratic formula at that point. But it's really a lot easier if you notice that we've got something squared, that's 3x plus 1 squared, equal to a number. And so just by using the square root method, we can, that's really what this is set up for. Let's take the square root of both sides. Oops, I'm sorry, I forgot about finishing up on number 2 there. If we take the square root of both sides, on the left side, we know that when we have something squared and we take the square root of that, we get what's inside. And of course, the square root of 49 is 7, so we're going to get plus or minus 7 on the other side. Now, I need to solve for x, so let's subtract 1 on both sides. We're going to get 3x equals. Now, I like to put my negative 1 between the plus or minus and the 7, so let's put it like that. And we still need to solve for x, so let's divide each side by 3. And so we are going to get x equals negative 1 plus 7 over 3, that's the positive case. And x equals negative 1 minus 7 over 3, that'll be the negative case. Remember, when you have that plus or minus 7, that means there's 2 answers. And these are our 2 answers. In fact, normally when we solve quadratic equations, we're expecting to get 2 answers. So negative 1 plus 7, that's going to give us 6 over 3, which is 2. And negative 1 minus 7, we're going to get negative 8 over 3, and that's done. So our final answer is 2 and negative 8/3. Alright, let's move on. Alright, so here we're finding the domain and range of these functions. Now, it might help to remember that our domain is normally all real numbers except for 3 special functions that we worked with this semester. The first one is, in fact, the radical function on part A there. We know that we can't take the square root of a negative number, so whatever's inside the radical we know has to be positive or it could equal 0. So with radical functions we have some restrictions. The same thing is true with rational functions, or when we have a fraction. We know we can't have a denominator of 0, and so for that reason we normally have restricted values. And then the other one would be with logarithmic functions. So otherwise we're expecting to get domains of all real numbers. So on letter A, this is one of our cases where we have a restricted domain. So let me go ahead and put some graphs in here. We know on number 1 that x plus 3 has to be either 0 or positive, so we set it greater or equal to 0, and when we solve that we'll get x is greater or equal to negative 3. And so our domain is negative 3 to infinity. Now, to find the range, we normally need to graph a function. So in this case, this is the square root function, which we call the ET function. It normally looks like this. But we've got that plus 1, or the positive 1 here. And so that's going to move things up 1. And we got this plus 3 inside the radical, which will cause a horizontal shift left 3. And so let me go ahead and erase these here. Our graph ends up looking like that. So you can see that the range, we'd start at the lowest point, and the y value there is 1, and then go to the highest point. There is no highest point, so our range is 1 to infinity. Alright, on part B, this is not one of our 3 restricted domain functions. This one, in fact, would be a parabola. In fact, we had this is the vertex form is what we called it. We can actually find the vertex quite easily here. But first of all, we know the domain is all real numbers because it's not one of our 3 special functions that have restrictions. And we'll see that when we do the graph. Now for the range, we do want to do the graph. Now because of this -3, well, first of all, normally our quadratic functions are parabolas that are at the origin, or the center's at the origin. The vertex is at the origin. But in this case, we're going to have some shifts. Because of the -3, we're going to go right 3, and because of the +4, we're going to go up 4. And so the other thing is, notice the minus out front. That's going to cause the graph to open down. And so it's going to look like that. So notice we went 3 to the right and up 4. Our vertex is at 3, 4. And it opens down. Graph opens down. So when we find the range here, it's going to be negative infinity to 4. There is no lowest point. Remember, we go from the lowest point to the highest point. Lowest point, there isn't any. Our highest point, the y value is 4, and that's why it's negative infinity to 4. Alright, for letter C, this is another one of our functions that has restricted domain. Alright, so first of all, it's clear that our restricted value here is 5. If you put a 5 in the denominator for x, 5 minus 5 is 0, we're undefined. So 5 cannot be plugged into this function as an input. Everything else is okay. So our domain is all real numbers except 5. Notice I've got parentheses around the 5. 5 is not part of the domain. And then let's go ahead and graph this for the range so we can see the range. So we know wherever there's a restricted value, we have a vertical asymptote. And so there'll be one at 5. And we also need to find the horizontal asymptote. Well, notice here the degrees are 1 in the numerator and denominator. So this is what we call balanced. And we would use 2 over 1, y equals 2 over 1, or 2. That's where we're going to have our horizontal asymptote. And you could actually find the y-intercept quite easily, and it's right there. We learned that when we only have one vertical asymptote, there's going to be an arc. We're going to have to figure out if the arc is either in this region here or this region here. And because we have that point, we know it's down below. And then there will be an arc on the other side. We've got to decide if it's going to be here or here. And you can plug in like a value like 6, and you'll find that you're going to be up above. And so that's what the graph looks like. And that means our range, let's see, going from the lowest to the highest point, we're hitting everything except notice we're skipping 2. And so the domain is all real numbers except 2. And that's how we write that. All right, so D is not one of our 3 functions that have restricted domains. In fact, we learned that the exponential functions have domains of all real numbers. And again, we'll see that when we do the graph. Now, normally when we draw a exponential function, notice if I'm just graphing y equals 3 to the x here, the base is greater than 1, so we go through 1, 0. And then the graph will look something like that with an asymptote right there. So the only thing we have to do here is, because of this 2, we're going to move everything up 2. So let me erase these marks, and I'll go ahead and put in the graph. And it looks like that. Alright, so you can see that our range, our lowest point, we don't quite get to 2, so it starts at 2. There is no highest point, so it's 2 to infinity. And now we have our last one, and again, the logarithms are where we do have a restricted domain, normally. And x plus 1, we know we can't take the log of 0 or a negative number. In fact, x plus 1, has to be greater than 0. So these are real similar to our square root function, but instead of being greater or equal, it's just strictly greater, because you can't take the log of 0. So we can solve this, and we get that x is greater or equal to negative 1, which means our domain is negative 1 to infinity, not including negative 1. Now again, to graph this, or to find the range, we would want to look at the graph. Now normally, I notice here our base is 10. It's understood to be 10. Normally we go through the point 1, 0 when our base is greater than 1, and the graph looks like this with an asymptote right here. But because of this plus 1 here, we're going to have to move everything left 1. Remember, this is a horizontal shift, so in this case it would be left 1. And so the graph would look something like that. And you can see our range, because we moved everything left 1, normally our asymptotes at x equals 0, here it's at x equals negative 1. Actually, I'm sorry, as far as the range is concerned, that's not even affected. But you can see that our domain does go from negative 1 to infinity here, and our range is all real numbers. In fact, we learned with exponential functions and logarithmic functions, they're inverses of each other. With exponential functions, our domain is all real numbers. With logarithmic functions, our range ends up being all real numbers. All right, let's move on to the next page. All right, so on number 5, we're finding f of x plus h. So let's go ahead and make a shell for the function, and our input is x plus h. So wherever there was an x, now there's going to be an x plus h. So notice we've got 2 times x plus h squared. This is what I call FOIL in disguise. We're going to have to multiply 2 x plus h's. So let's do that off to the side. X times x will get x squared. X times our outer product will be x. So remember, it's first, outer, inner, last. Our outer product is xh. Our inner product will also be xh. I could write hx, but I'm going to write them the same way. And then our last product is h times h, or h squared. We do have a couple of like terms here with coefficients of 1. A 1xh and another 1xh makes 2xh. And so let's go ahead and plug those into parentheses here. You do have to have the parentheses because we're going to have to distribute the 2. And then we'll distribute the 3 times the x, that's 3x. And 3 times h is 3h. And then don't forget the minus 4. We still need to distribute the 2 here. So it'll be 2 times x squared, 2 times 2xh, which is 4xh, and 2 times h squared, 2h squared. And then let's write the rest of it out. And in fact, we're done. If you look at all those terms, none of them are like terms. None of them have the exact same variable factors, or the exact same variables to the same power. Okay, last one for this video. Let's look at number 6. This is a rational equation. So first of all, we want to look for any restricted values. Notice that x cannot be negative 1 here, because then we would be undefined. You plug negative 1 into the 0, you get 0 in the denominator. Now, to solve a rational equation, we start by clearing the fractions. And so we're going to want to multiply by our LCD, which is x plus 1. We only have one denominator here. So let's multiply each of the terms by x plus 1. We're basically multiplying both sides of the equation by x plus 1. And when we do that, we have to distribute on the left side. So notice with the first fraction here, we can cancel the x plus 1's, and we get 1 times 6, or just 6. On the other side, on the next fraction there, we can cancel the x plus 1's, and notice we're left with 1 times 6x, and that's 6x. On the other side, we're going to distribute the x. X times x is x squared, and x times 1 is x. This is a quadratic equation. So we want to get 0 on one side and everything else on the other. So I'm going to subtract 6 and 6x on both sides. So we'll get 0 on the left. The x squared has nothing to combine with, so we'll just rewrite that. Excuse me. And then x and a minus 6x, that's 1, and a negative 6 is negative 5x. And don't forget the minus 6. And so this is something we should be able to factor using the AC method. And I'll just go ahead and factor it. And you should get x minus 6 times x plus 1. So x is going to be 6 and negative 1. And notice we said x can't be negative 1, so we have to throw that answer out. You can verify that 6 does work, and that is our only solution here. So I'm going to go ahead and stop here at this point and then pick up in the next video.